Good morning, students, and I welcome you all for the digital classroom of General Science. Dear students, in the last lecture, we had already started with lesson number 5 inside the atom, and today we are going to continue with the remaining part of the lesson. So, let's continue with the lesson. Going to start is distribution of electrons. We had studied about the structure of the atom, and we had also studied that it has three constituents: neutron, proton and electron. Neutron and protons are present in the nucleus and they are called as the nucleon, and the electrons, they revolve around the nucleus. An atom does not have any charge because the number of protons and the number of electrons are same, and we know that protons have a positive charge and electrons have a negative charge. So equal number of positive charge and equal number of negative charges, they nullify each other, and thus the atom does not have any charge. So with this revision, let's continue with the next topic, distribution of electrons. Now, how these electrons are distributed in the atoms. Now, as I said, these electrons, they revolve around the nucleus in their own orbit, right? And a symbol N is used for the ordinal number of the shell, right? So, the nearest shell of the nucleus is called as K. Next to it is L, next M, and next N. As you can see in the picture, the very first one is K, first energy shell, second energy shell is L, third is M, and the fourth one is N. Now, the electrons, how many electrons can be accommodated in these orbits? Now, this depends upon the number of the energy shell. Now, the total electrons in an orbit is equal to 2n square. That is, 2n square is the formula by which we can find out the maximum numbers of the electrons in that particular shell, and n is the number of the shell, right? Now, the nearest shell, that is K, to the nucleus, it has the lowest energy. And as we go away from the nucleus, the magnitude, that is the magnitude of the N increases, the energy of an electron in that shell also increases. Okay. Then the next topic is electronic configuration of elements. Now, electronic configuration means what? The electrons in an atom are distributed in the shells according to their maximum capacity. The shell-wise distribution of the electrons in an atom of an element is called the electronic configuration of that element. Now, in the previous paragraph, I had told you that 2n square is the formula to find out the maximum number of electrons. And as we change the orbits, the number of the electrons also changes, right? And as we go away from the nucleus, the number of electrons also increases. So, this distribution of the electrons in an atom is called as the electronic distribution of the electrons in the shell. Now, each electron has a definite energy as per the shell in which it is present. And as I said, as K is the nearest shell, so K has the lowest energy. And then as we go towards outer side of the nucleus, that is LMN, the energy of the electrons goes on increasing. Now, I had shown you a table in which we will just go through the electronic configuration of some of the elements. Now, as you can see, we have a table in which the very first one is atom, Next is symbol. We know that the abbreviation of the name of the element is called as symbol. Third is electron number in atom. That is how many electrons are present in that element. Next is KLM8. Now we know the formula 2n square. That means in K, maximum number of electrons will be 2 into 1. 2 ones are 2, right? So that is the maximum number of electrons. In L it is 2n square. Now n is 2, right? So 2 2s are 4 and then 4 into 2 8. Likewise M 18 and 32. And the last column shows the electronic configuration in numerical form. So let's see, hydrogen symbol is H, electron 1, it is in K and electronic configuration 1. Sodium Na 11 2 8 1, lithium 3 2 and 1, bromine Br 35 2 8 18 and 7. Okay, so this is how the electronic configuration is done. Next is valency and electronic configuration. Is there any relation between the electronic configuration and the valency? Yes. The number of chemical bonds formed by an atom. So valency is how many chemical bonds the atom can form. That is called as the valency. And it is constant in its compound. Now, how this valency is determined? Now, valency of an atom is determined by configuration of its outermost shell, right? So, the number of electrons present in the outermost shell is equal to the valency. Thus, the outermost shell is called as the valency shell. It can be K, it can be L, it can be M depending upon the shells present in the atom. So, valency electrons are nothing but the electrons present in the outermost shell, and that number denotes the valency of the atom. So, next is isotopes. Now, what are isotopes? The atomic number. What is atomic number of an element? We had studied the atomic number is the number of protons present in the nucleus, and we had also studied the number of protons is always equal to number of electrons. So the atomic number is the number of protons, right? And it is number of electrons also. Now, we had studied the valency just in the previous topic, that the number of electrons present in the outermost orbit is called as its valency. And what is valency? Valency is the chemical bonds which the atom can form. So, that is its chemical identity. So, thus the isotopes, the definition will be as: the atomic number is a fundamental property or the basic property of an element and its chemical identity. So, the elements having the atoms with same atomic number but different mass number are called as isotopes. That means its atomic number will be the same, but the atomic mass number is different. Now, just to revise, as I said just now, atomic number is equal to number of protons or number of electrons. Then what is atomic mass number? Just try to recollect, students. Atomic mass number is the number of nucleons. And what is a nucleon? Nucleon is the total of protons and neutrons, right, that are present in the nucleus. So, the number of protons and neutrons is the atomic mass number. Atomic number, proton or electron. Mass number, proton and neutron. So, what is the difference? The difference is the number of neutrons. That means in these atoms, the number of protons and electrons are same, but the number of neutrons are different, right? So the atom of the same element having different mass numbers are called the isotopes. Now we had also studied that when we write the symbol C, like if we take the example of carbon, right? Now there are three isotopes of carbon. That means there are three types of atoms of carbon in which the atomic mass number is 12, 13 and 14. Now we know that it is also expressed as 12C, 13C, 14C. If you remember, this is called as superscript. This is the atomic mass number, and below the C, that is written as atomic number, right? That is the subscript. Now what does these three carbon atoms express? C12, C13 and C14. Now that means in the first C12 atomic mass number, the total of neutrons and protons is 12. Whereas in 13C, the number of protons and neutrons is 13. And in the third one, the number of protons and neutrons is 14. So what is different in these three? The number of protons is same, but the neutrons are different. Got it? So these are called as the. Then, is there any use of these isotopes? Yes, there are so many uses of isotopes. Isotopes of some elements are radioactive and they are used in various fields such as industry, agriculture, medicine and research field. Now the very first isotope is uranium-235. That is the isotope of uranium. So this uranium-235 is used for nuclear fission and production of electricity. Second one is some radioactive isotopes like cobalt-60 are used in the medical treatment of fatal diseases like cancer, right? There is a treatment, the radiotherapy is, the chemotherapy is given in cancer, that is with the help of the cobalt-60. Third one is iodine-131 used in treatment of goiter, disease of thyroid gland. Some people, they develop a bulging structure or a swelling in the neck region, front side, that is a throat region, and that is called as a goiter, right? So for that, the iodine-131 is used. Then radioactive isotopes are also used for the detection of cracks in underground pipes, right? And that isotope is sodium-24. Next is radioactive isotopes. They are also used for food preservation from microbes. When we preserve the food for a longer period of time, after some time, the microbes, they, infect the food. So, to protect them from the microbes, the food preservation method, radioactive isotopes are used. And the last one is radioactive carbon-14, C14. It is used for determining the age of archaeological objects. This you will be studying when you will go to your 10th standard, how to determine the age of archaeological objects. Okay. So, students, this is all about the uses of the isotopes. Next is nuclear reactor. Now, what is a nuclear reactor? It is a machine that generates electricity on large scale by using atomic energy. The nuclear energy in atom is released by bringing about nuclear reactions on the nuclear fuel. Nuclear fuel is the raw material which is used to produce the electricity, right? And in this, the atomic energy is used. So, now in this machine, right? Where the electricity is produced with the help of the atomic energy. What happens exactly? Now here the nuclear fuel, that is the raw material which is used, is the uranium 235. We had just studied the uses of the isotope. So isotope of uranium, that is uranium 235, it is used as a nuclear fuel. Now, on bombardment with slow speed of neutrons on this uranium 235, it undergoes fission to form nuclei of two different elements. See students, there are two words, fission and fusion. Fusion means to unite and fission means to break. See, you can see in the picture uranium 235, it is unstable. When it is bombarded, it turns into uranium 236 and then it divides into two. One is Crompton 92, right? And the other one is barium. Krypton 92 and barium 56. So this one is divided into two, so this is called as fission, right? So with the help of the nuclear fission, the energy is produced in this. So when this uranium 235 is bombarded by neutrons, a chain reaction of nuclear fission takes place, which you can see in the picture, and this reaction, once it starts, it doesn't stop, it continues. So what will happen? The number of atoms are increasing. One uranium 235 is dividing into two, then again the other one will divide into more. So this chain reaction, now how to control this? So to control this chain reaction, it is to prevent the probable explosion. Otherwise, it can explode. So we have to take precautions. Now how we will control? We will control the chain reaction in the nuclear reactor as it is necessary to decrease the speed and number of neutrons. Now for this purpose, there are following following provisions. The very first one is moderator and the second one is controller. Now what is a moderator? Now moderator is a graphite or heavy water which is used to reduce the speed of the neutrons, right? So this is how the speed is moderated. Second one is controller. Now controller means to reduce the number of neutrons. Now how these number of neutrons are reduced? They are reduced by absorbing them by the rods of boron, cadmium, beryllium. Okay. Then water is used as a coolant to take out the heat. Now we know that when water is allowed to cool down, it converts into steam. So this water is converted into steam, and with this steam the turbines, they start rotating. Now when these turbines, they start rotating, what will happen? The electricity is generated, right? So this is how the nuclear reactor works. Now in India there are 22 nuclear reactors which are situated in 8 different places. The very first one is Apsara at BARC Mumbai, which is the first nuclear reactor in India, right? So with this we finish with the lesson, and now let's start with the workbook exercise because still we have time. So I am giving you 2 minutes, students. Go and bring your workbooks and textbooks immediately and a pencil also. Come on quick. And those who are already sitting with their workbook and textbook with them, they will be ready. See students, certain things even you have to understand and you have to realize when the lesson, a small part of the lesson is remaining, then for the next period you should be ready with your workbook as well as the textbook. Okay, so now let's start with the workbook exercise, and the very first question is fill in the blanks. Electron, proton, neutron are the types of dash in an atom. What are they? They are the subatomic particles. Second one, an electron carries a dash charge. It is a negative charge. The electron shell dash is the nearest to the nucleus, and that is K, the very first one. The electronic configuration of magnesium is 282. The valency shell of the magnesium is, yes, we had studied that the last one is the magnesium is the valency shell. So it will be M, K, L, M. Okay. Then the next is fifth one. The valency of hydrogen is 1 as per formula H2O. Valency of Fe is dash as Fe2O3. We know that the subscripts written are cross multiplied. So 2 goes on oxygen, 3 goes on iron, and thus the valency of oxygen will be 3. The next one is except dash, the nuclei of all atoms contain neutrons, and that is hydrogen because it does not have neutron. Dash are emitted by radioactive elements. It is the alpha particles. Then the next question is find out my partner, that is match the columns. The very first one is proton, and the answer is C, positively charged. Second one is electron. The answer is A, negatively charged. Third is neutron, and the answer is B, that is neutral. They do not have any charge. Now the third one is name the following. The very first question is a positively charged subatomic particle in the atomic nucleus, and we know that it is proton. Second question, moderator used for reducing the speed of neutrons in the nuclear reactor. Just now we had seen it is graphite. Third question, a machine that generates electricity on large scale by using atomic energy. It is none other than nuclear reactor. Fourth one, the symbol used to denote atomic number is the very first letter of the alphabet, that is capital A. The next one is fourth one, and that is define the following terms. The very first one is atom. and this is given in your textbook, page number 28. So open page number 28 and the very first paragraph, second line. An atom is the smallest particle of an element which retains its chemical identity in all the physical and chemical changes. Second one is isotope, and that is again given in the textbook on page number 36. Page number 36. In the center of the page, the heading is given with red color, isotopes. So you will start from the first line. The atomic number is a fundamental property of an element and its chemical identity. Second point, some elements in nature have atoms with same atomic number but different mass number. And the third one is, such atom of the same element having different mass number are called isotopes. Then fifth one is moderator in nuclear reactor. It is also directly given on page number 37. The moderator is written with the red color bold letters in the second half of the page. Graphite or heavy water is used as moderator for reducing the speed of the neutrons. Sixth one is extra nuclear part, that is given on page number 31. So come to page number 31 and we are talking about the sixth one. So the last heading of the lesson of the page, extra nuclear part, it's clearly given. The extra nuclear part in the atomic structure includes electrons revolving around the nucleus and the empty space in between the nucleus and the electron. Seventh one is nucleons. It is also on the same page number. We have to go to the upper side of the page, and you can see that it is given on page number 31. So you can see the direct heading nucleus is given, and in that you will start from the third sentence. The nucleus contains. Did you get it? Yes. So first point, the nucleus contains two types of subatomic particles together called nucleons. Second, protons and neutrons are the two types of nucleons. Eighth one is valency electrons, and it is again given directly in your textbook on page number 34. Page number 34, in the first column of the page, the second last paragraph, you have to start from the fifth line. Valency of an atom. Did you get it? Fifth line on page number 34, first column. So first point is, valency of an atom is determined by the configuration of its outermost shell. Second point, therefore the outermost shell is called valency shell. Third point, the electrons in the outermost shell are called valency electrons. In the third point, you will not write the word also. Okay. With this, we finish with the fourth question. Then let's go to the fifth one. Answer the following question in one sentence each. The very first question is, how many types of subatomic particles are found in an atom? And it is electron, proton and neutron. Second question is, which subatomic particles are electrically charged? And we know that electrons are negatively charged and protons are positively charged. Third question, which subatomic particles are present in the nucleus? Nucleon, it consists of neutrons and protons. Fourth one, what are electrons revolving, where are electrons revolving around the nucleus placed? They are the orbits, right? So they are in the orbits. Fifth one is, what are the symbols used for the shells which accommodate the electrons in various atoms? And we had seen that it is alphabets K, L, M and N. Next is, what is the symbol and ordinal number of the innermost shell? The innermost shell is K and the number is 1. Then the next one is, write symbol of electronic you have to change this question. It is wrong. It is, write the electronic distribution of fluorine atom. Electronic distribution of fluorine atom. Okay, and it is 9. So it comes to 2 and 7. Correct? K, first one 2 and second one is 7. Eighth one, outermost shell of fluorine atom, as it is having only 2 shells. So first one K and the second one is L. Ninth one, outermost shell of sodium atom. It is M, because it has 11 electrons, and when we distribute it comes to 2, 8 and 1. So K, L, M. Third one M. Next, which is the outermost shell of hydrogen atom? It has only one shell, that is K. 11th is, what is meant by atomic number of an element? Now this is also directly given in the textbook, page number 31, and we had once written that answer also. So it is the same one which was written as 4.3. I am reading it again, page number 31, proton heading, and the same answer as 4.3. The first point, the number of protons in the nucleus of an atom is the atomic number of that element and is denoted by Z, and it is called as the atomic number. Next is, why are atomic numbers and atomic mass numbers always in whole numbers? Now this you have to just jot down the points, because atomic mass number is equal to the protons and the neutrons present in the nucleus, and atomic mass number is equal to the number of protons or the number of the electrons, right? So as the number of protons and neutrons are always a whole number, the atomic mass number is always a whole number. Friends, the time is almost up, and we had already started with the workbook exercise of lesson number 5, but we are able to finish up with only the first 5 questions of the workbook exercise, and remaining questions we will be completing in the next lecture. So students, the same humble request that please keep completing your workbook so that your work doesn't remain pending. Thank you. Take care. Stay home. Stay safe.